So there are two main areas that we want to look at when we're trying to improve the quality of our products. And the first of these is requirements management. And so requirements are really often the most overlooked way to improve quality. We find that pretty much every organization knows they need to do it better, and yet very few actually take steps to improve their requirements management processes. And oftentimes, development issues that stem from requirements are misdiagnosed. And so what I mean by this is that oftentimes a project will go badly and we'll think it's because, oh, well, we didn't write our code fast enough. So we'll decide that the solution is, well, we'll throw more developers and more resources at this problem. But without the proper requirements management, all we're really accomplishing here is that we're giving ourselves the ability to produce more buggy code faster. So instead, what we need to do is attack this problem at its root and manage our requirements and specifications better. The second area where we'll want to focus is our test cycle management. And mainly this refers to regression testing. So we still do things like unit testing and development testing, but we'll use our test cycle management to take things a step further and thoroughly ensure the quality of our products before we ship them. And also, regression testing doesn't necessarily have to be testing every single piece of functionality through every permutation of our product. You know that oftentimes with large products being released on multiple platforms, it's really just something that's not feasible. So what we can do is break our regression test into modules and use things like spot coverage to test a good representative sample of our product. So there are a couple of things that we want to look for when we're selecting a requirements management solution. And these are sort of basic criteria that you're going to want in any solution you select. Central repository for your test results, web-based access for remote users is extremely useful. You're going to need extensive account types and permissions to manage how people are accessing things. And then you'll want to be able to plan your workflow and manage how you're going to take your specifications from design to development, as well as have some automated tracking and integration, and of course full traceability into how your requirements are being developed and tested, and reporting and analysis. And so we can give this full traceability by putting the design at the center of our process, which is something that we do through various linkings within our products. And so this is an example of a basic Agile development process where our product begins at conception. We'll go through analysis, planning, implementation, and testing. But what we want to make sure of is that our design or our requirement specifications stay in focus throughout this entire cycle. We can then deliver our product, get feedback from our users, and then begin the process all over again. The other thing we're going to want to do with our requirements management is we're going to need to actually first understand how development processes have sort of evolved over time and how that's affected how things like requirements and test cycle management are done. So we're probably all familiar with a waterfall process, which is sort of how everyone started out software development. It's called waterfall. It's often planned using a Gantt chart, so you complete one phase before moving on to the next phase of development. And so we can move left to right here in this diagram, but once you move down a phase, you ideally do not want to revisit a phase above. So this waterfall approach tends to be very high risk. It's often more costly and generally less efficient than an Agile approach. And this is because you usually don't realize any value until the end of the project when you deploy, and you leave testing until the end, which means your issue discovery is happening very late in your process, and you also don't seek approval from your stakeholders until you review, which is, again, near the very end of your process. And if the requirements have changed, then you're going to incur a huge amount of cost trying to make adjustments. So the waterfall approach eventually gave way to an iterative approach, which focuses on delivering a sprint or iteration of software as opposed to the entire product at once. So within this, we can again go left to right. So we can revisit phases at this point. So if we're in the build phase and there's a change in requirements, we can always go back to the planning phase until we actually deploy and move down a step. The most commonly occurring issue when we're using something like iterative development, at least in my experience, tends to be bottlenecking. So for example, you'll deliver a lot of code toward the end of your schedule and then leave it until the last minute to test everything. And then an issue can take longer than expected to resolve, and you miss your sprint deadline and end up delivering nothing. Another really common symptom of this approach is there tends to be an overcommitment at the beginning of the sprint, since it can be fairly difficult to estimate the total effort when we're first beginning. This approach is definitely a little less risky than waterfall, but there's still a lot of room for improvement here, which is where processes like Agile and Scrum come into play. And so with Agile and Scrum, we, instead of focusing on delivering a sprint of work, we're focusing on delivering fully tested, independent, valuable, small features. And this allows us to diversify our risk. So if one feature goes wrong, it shouldn't impact another feature, and we can possibly still release at the end of our sprint. One of the problems we'll find within a Scrum approach, though, is that requirements tend to become almost ad hoc and ill-defined very frequently. And so if you have ill-defined requirements and you're going through these quick development cycles, you're going to end up having to do more development cycles to fix issues that should have been found during the requirements phase. So what we can do then is extend our requirements phase to make it a little bit longer, similar to an iterative approach. An iterative approach typically uses something like use cases, whereas a process like Scrum or Agile will use much shorter user stories. And what we do is we pick something sort of in between, maybe something like user stories with acceptance criteria, or just spend more time developing use cases. We can then still develop individual features and then do a full review and deployment cycle at the end. And the review cycle is where things like regression testing will take place and our various test cycles. So what are we going to use to manage the test cycles now at the end? So the tool that we provide is DevTest Studio. This consists of a test management module, which is DevTest, and a development tracking module, which is DevTrack. The test management module will give us our test library creation. We can integrate with a variety of automated testing tools, handle our release and test cycle planning, and of course our manual test execution, and then do reporting and analysis at any point. With the development tracking tool, we'll use that for our defect and issue tracking, as well as managing our feature and enhancement tasks. We'll get a fully configurable workflow for our development process, as well as source control management integration, and again, full reporting and analysis. So at this point, we'll jump into a live demonstration of DevSpec and then DevTest Studio. And just 1 second while I pull that up. So what we're looking at now, this is actually the dashboard from DevTrack. This dashboard is the same dashboard that will be available within all of our product lines, and this will just give whoever your team member is a way to manage their workload as they see fit. It's full widget-based, so you can drag things around and arrange them however you want. And you can customize all the reports that appear on this page. Here we have an open incident list, and we can drill into customer issues and see what developers are actually handling them. So this is a great starting page to kind of get a quick snapshot of your workload at the beginning of the day. If we jump over to DevSpec now, what we're looking at is our Wiki view, and this is where we're going to go to design our specifications and sort of begin the whole requirements management process. You have this full tree on the left. You can organize your product however it makes sense for you. We have our product here at the top, and then we have various modules, and then we've broken it into requirements and specifications for each of the modules after that. When we're designing our specifications, we have a full, what you see is what you get text editor. This is HTML based, so we can actually do really neat things like I can copy and paste the content from a web page and just paste it directly in. So pretty much anything you can do with the web page can be done within this text editor. Anything that you can't communicate within this text here, you can of course attach, so things like Visio documents, PSDs for design, they can all just be attached directly to the specification. We'll also see some basic linking within this Wiki view too. So here I have a link to a knowledge item. So we provide a central knowledge base where you can store best practice articles or information articles and actually link them to any of the other items within any of the other modules. So I can link knowledge items to specifications here, development tasks in DevTrack, or tests within DevTest. In this case, I've linked to an article that's related to the racetrack that's being developed for my game. We'll also see a link to the requirements. So this is a specification, and requirements are signified by this green star here. And in this case, the requirement is set up as a parent to this specification and these other specifications as well. So I can see all that linking right within there. When it comes time to begin managing the workflow of my specifications and actually taking them through approval processes and eventually through development and release, we'll go into the task view. So if I pull up this specification here for a race cart, we'll see the basics here. We can do quick edits to the spec description on this page here. So if I want to add more neat features, I'll add that here and fix my typo. If I save this, we can actually do automatic versioning within here as well. So you'll see that I've generated a new version of my specification, and if I need to, I can roll back to any of the previous versions. The History tab here offers a graphical look at the workflow that my specification has been going through. So in this case, we'll see that my specification started out in a functional review, went into a technical review, before going into this ready to implement phase. And now that it's in ready to implement, it would make sense to send it into a coding phase. So if I want to send it into a coding phase, I'll click this coding button here, and then I'll hit save once that finishes loading, and that'll go ahead and take it into the next state. The next thing we're going to want to do is actually move it into the product backlog. The way the backlog is going to work is it's a full listing. This is basically a pool where we'll put our specifications once they're through our workflow process. We'll place them in the product backlog, and this is basically where our product managers will prioritize and plan out development cycles. Once everything's prioritized in here, we have a number of options when it comes to how we plan out our development cycle. Typically, this will be done within DevTrack, which we'll look at briefly here. So we have a number of views available to us within DevTrack, the most basic of which is just a listing view. So here I'm listing out all the tasks for all my members within my current development sprint, which is Sprint 6. Over on the left, we'll see the different specifications that are being addressed. And then over here is all the tasks that are linked to these specifications that I need to complete to deliver my product. We have another view here, which is our storyboard view. This is basically a digital version of index cards that are used within a Scrum process. In this case, I'm arranging them by date, so I can schedule out my tasks on individual days. We also have the option to group by progress status, in which case we get these swim lanes. And this is really useful for finding out if a whole bunch of my tasks are bottlenecked in a particular state. This actually looks pretty good. When I want to plan something, I can just drag items from the backlog either into an individual developer's to be planned section if I want to make sure that it's that developer that develops it during my sprint, or I can use the to be planned section of this unassigned user, and that'll basically be a pool for development. So when a task isn't unassigned, it means that it needs to be completed within this sprint, but it's up to the development team to self-drive and decide who's actually going to complete the task during the development cycle. If I need to create a new task, whether it be a task that's related to a specification or a standalone task for something like a defect, I'll bring up this new task dialog. And we're actually going to see that this same dialog will appear within DevTest if a test should fail at any point and we need to create a defect for it. And that is part of the linking between DevTest and DevTrack. All the fields on here are fully customizable. These red fields are required fields, and then we've set up optional fields here like type, urgency, and component. And this is the same full HTML. What you see is what you get text editor as well. The workflow within here is managed from the admin. So we give you a graphical workflow editor, and this is a example of what kind of workflow we would set up in the admin. If I needed to create a new state, it would be really simple. You can just right-click and add new states, and then drag between states to link them. And because we have this graphical representation, it makes it very easy to communicate to your team exactly what the process is going to be for development so that everyone's on the same page. And you can also have a completely separate workflow when you're designing your specifications, as well as multiple workflows between multiple work projects in DevTrack. A couple of other quick things we can look at within here. We can see the issue detail where we'll again get the workflow of the states that's been through. And current status is where we would update things like the amount of time remaining on a particular task. These time tracking fields can actually feed directly into DevTime, which is our time tracking module. So if you are doing things like time tracking, you basically can have your developers enter their time once, and then it will feed directly into this time management software where they can submit timesheets for approval, and you can report on how much time is being spent on various types of development tasks. The we definitely need to talk about the Burndown Report, and this is going to be used within any Agile process. The idea behind a Burndown is that you will have your estimate at the beginning of your iteration. So in this case, we're estimating it's going to take 288 hours to complete all the work needed for our iteration. As work is being done throughout the sprint, developers will update their time remaining, and that'll cause this green line to burn down. The goal is to have it end at 0. We can look at the slope of this green line to gauge velocity and see if we're on track to deliver our sprint on time. In this case, it looks like we're in pretty good shape. We will also have the option in next week's release of the product to burn down the workload of individual developers. So what this will allow you to do is look at how a developer is estimating their tasks and then determine if maybe they need help with things like estimates. So if I look at the burn down for Sprint 1, this would be an example of a burn down where a developer would need help with their estimates, where I started with 200 hours estimated, but at the end of my sprint, I see that it actually took me 332 hours to complete that amount of work. That's the basics of how we would use DevTrack just for standard development. We now should talk about how we can integrate quality and test cycle management with these sort of standard development practices. And in order to do that, we will use DevTest. So DevTest is where we're going to build our test cycle library. Our test library will consist of test templates. You can think of test templates as basically a blueprint for a test procedure, and then we'll take these test procedures and organize them into test cycles, which have testing tasks, which is the actual task that will be executed by our development team. These templates are, again, like everything else in the interface, fully customizable, so I can add any fields here that I need to. In this case, we've gone with a fairly basic setup where we have a test procedure and expected results. We also are tracking an estimated ineffective time, which would be the setup time for a test, as well as an estimated effective time, which would be the actual time spent testing. And we can also add any file attachments to our templates. If we want to create a new test template, because we have this DevSpec integration, we will actually create it linked to a particular specification so that everything remains fully traceable and integrated throughout our process. So I will select this specification here, and I'll select to link it. What this will do is copy over the description of that specification into the description for my new testing template. And it might, so this is nice, it'll save you a little bit of typing. It might make sense here to actually move the acceptance criteria into my expected results. I'm going to go ahead and approve that, set myself to the template owner and save it. And I'll also go ahead and approve the other tests that are already sitting within this particular module of my game. For each of these templates, we also have the option to set up environment variables. And so this is an important concept to understand. Basically, the way this works is that we set up all the different permutations that our product is going to run on. In this case, we're developing our game for these 4 operating systems and in these 5 languages. And we'll see how these come into play when we actually begin scheduling out our test cycle. We'll also be able to see full linking again to any development tasks. Since these are new templates, there is really only the specification linked here, as well as attaching any notes. So let's go ahead and plan out a test cycle now. And so we'll see the way we were doing this previously is for version 1 of our product, we went and did a test cycle for each of the modules. And so we'll take a look at how that's done first, since that's a pretty common use case. We'll hit this new test cycle development, and let's do a weapon test cycle. So we'll make that weapon cycle. If I had previous test cycles, I could actually copy settings out of them. And this applicable defect project is an important piece of the integration. What this means is that if a test fails and I need to create a defect for that test, this will be the development project that I'm going to create that defect in. I'll go ahead and hit next. I get member selection, so I can, of course, pick whatever team members are going to be working on a particular cycle. And this requirements-based test planning is an optional page, and we recommend you use it if you have DevTest. So what it will allow me to do, if I go and plan my test cycle based on specification subproject, I'll go ahead and go into version 2 here, and I'll pick weapons, and this will give me all the specifications for the weapons system in my game. I'll go ahead and hit next, and then I can select my environment permutations, and this is where we set up our spot coverage. So if I were to select every single one of these permutations, I would end up with roughly 20 testing tasks for each of the templates. You can see how that would add up very quickly. So the idea here is we'll just pick out a sampling of these OSs and languages that is representative of the entire system. This will allow us to get good test coverage sort of efficiently. The functional tree is my other option for selecting my test templates. Because I've already filtered on specification, I can just select the top of the tree, and I'll get only the tests that are linked to the weapons template. Go ahead and hit next here, and I'll see a confirmation page. It's going to show me who my testing tasks are being assigned to, as well as what templates are being assigned. I can override any of these options here. We'll go ahead and finish that, and I'll create our weapons cycle. I want to real quick talk about the other option that we had while we were creating our development, our testing cycle, which is to sync it directly with development work. So in this case, I'm going to do a Sprint 6 testing cycle. We'll go and skip through these. And now when I get to my requirement-based test planning option, I'm going to select to base it on a development subproject. And what I can do then is select Sprint 6. This will give me all the specifications that are being worked on in Sprint 6, and then I can select the tests that are related to them. I happen to know that my test data for Sprint 6 is a little limited, so I'm going to go ahead and grab 2 more development cycles just so I have more testing data. Again, we'll do the environment permutations. Let me just grab a couple of these. And there we go. So when I come to the functional tree now, again, I can select the whole tree. I'll see all the tests that are related to my development cycles being selected. What we didn't talk about before, which we will now, is we also have this option to add query coverage or add coverage by query. And so this is a really neat feature that will allow us to do some cool things. One of the more basic examples is if we filter on task state, we can actually get all the tests that did not run or failed in a previous cycle and rerun them in a new cycle. And so that's a really useful thing to be able to do. We'll skip that for now, though. We'll hit next, get our confirmation, and then finish. So at this point, we've created 2 new test cycles, one tests all the weapons, and one that is synchronized with our development. And so what we've basically done here is had one test cycle to ensure that the needs of our stakeholders are met, and another test cycle that ensures that the needs of our development team are being met. So at this point, we now need to obviously execute the tests themselves and make sure that things are passing or failing. So I'll go ahead and I'll select my first test here. We can set this to in progress, and then this will mark it so that no one else will attempt to work on the same test that I'm already working on. We'll go ahead and enter in our ineffective or setup time. And then when we're running our test, we can just go ahead and hit the start button, which will start a timer down here, which will track how much time we're actually spending running the test. We have a number of different ways to track this field. You can, of course, manually enter your time, or we can hide it, but I like this one here. So once our test is completed, we'll go ahead and update this. Let's say that the first test passes. We'll go ahead and update that to pass and save, and then we're done with this testing task. We move on to the next one. Let's say that this one actually fails, as so often happens. We'll go ahead and save that, and what we get now is this defect submission dialog. So we have the option to create a new defect. We can search for an existing defect if we believe this test has failed previously and there's a related defect that's already been created, or we can associate a task to a defect that's already linked. We'll go with the basic case here and go ahead and enter in a title. Spike strip didn't work, and hit OK. And so now we're actually seeing the exact same dialog that we use for issue submission in DevTrack. And we'll go ahead and fill out the required fields, our version, platform, and language. And we'll even go ahead and fill out these optional fields as well. Enter a description, test failed, and then go ahead and submit this. And that'll send the issue over to DevTrack, where it can then be managed and moved into a development cycle. And so that's basically how we get the integration between our testing and our development. Now, as we're going through this, we're going to need the ability to, of course, report on the work that's being done. And ideally, we wouldn't have to have, say, an executive level manager going and bothering our development team trying to find out the status of their requirements. And so that's where this traceability report comes into play. This offers a quick, easy way for anyone you give access to, really, to see the state of all the requirements and specifications in the system. So here, I can see my track requirements. I can see the status of that requirement. I can see all the specifications that are being used to address that requirement. Then for each of the specifications, so I have the first one here below, I'll see the requirement again that's linked to. I'll see the development items that it's linked to, and I can see the state of it. In this case, there's just the one task. And then I can also see all of the tests that are linked to it as well, and the state that they're in. And I can customize all these columns to see different things. So in this case, I've chosen to see the full spec description and not see what's going on in development and testing. The other option, which I don't believe we touched on, was there's an All Links tab within this task view, and this will allow me to see, again, all the work that's being done. So in this case, I see that there are 2 templates set up for this specification, and if I grab a specification that's currently being worked on, I'll be able to see, again, the knowledge, the requirement. I'll be able to see all the development tasks being worked on. I can actually click right in. I can see the workflow that this development task went through and find out what state it's in, who's working on it, pretty much an entire history of the work that was done on it. And then I can also see, again, the testing template and what tests were run, what their state was, and who ran them. So we give you full traceability from requirements all the way through development and testing so that you can ensure that your stakeholder needs are met. So that will pretty much wrap up what we wanted to go through with this presentation. We can do some brief Q&A now. We'll go ahead and look at questions. Great. We have, which automation tools integrate with DevTest? So DevTest, we provide a test link module, which will give you an out-of-the-box integration with Test Complete. And it will also provide an API for integration with a variety of other testing tools. And we're working on an out-of-the-box Selenium integration as well, and that will be coming soon. Let's see what we have next here. Once the requirements are put into the backlog, how can the requirements be changed? They flow back into your requirements tool, or can the development team modify the requirements on the fly? So the idea behind requirements management is that the requirements modification should be done within DevSpec through that controlled workflow. Once they go into the backlog, they're ready for development iteration. Once that iteration completes, that's typically where we would get the feedback from the users, the end users, and make modifications to our specifications. We would modify those specifications within DevSpec and then reschedule them for another development iteration. We can also, again, reschedule them if we need to based on development feedback. So if a change needs to be made to a requirement because some part of the UI is not physically feasible, we can make those changes within DevSpec and then push them into the backlog again to schedule. So yes, requirement changes can be made on the fly and they can flow back and forth. Does DevTest have an ODBC interface available? Yes, we can give you full ODBC access. We can give you a database diagram, and that will allow you to write your own custom reporting scripts or address any integration needs that you need there. So how do we know that stories are the right size before the development team estimates them? So best practice when you're making estimates for your stories, and maybe this relationship wasn't made clear while we were going through. So the relationship between a story, and we consider stories to be the same as specifications, and the development task, is that tasks are basically children to a story. So you're going to break your story up into the tasks that you need to complete to develop it. You know that, so the issue really isn't if your story is the right size. You'll know if your story is the right size when you start breaking it up into tasks. If you find that all of a sudden you've broken your story up into 100 tasks, then your story is probably too broad and it would be categorized as something more along the lines of an epic, and you should break it down possibly into themes and various user stories. Each of the tasks you're going to want to try and limit to 5 hours. That's sort of a standard